Python has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type list. Hey everyone, welcome back. In today's video, we're going to explore one of the most useful and flexible data structures in Python, the list. If you've ever needed to group items, store collections, or work with sequences, lists are your go-to tool. Let's dive into what makes lists so powerful. In Python, a list is an ordered collection of items, which can be of any data type: numbers, strings, booleans, even other lists. Lists are written using square brackets with elements separated by commas. Here are a few things to know. Lists are mutable, which means you can change them after you create them. They maintain order, so each item has an index starting from 0. Lists can grow or shrink in size dynamically. Under the hood, they're similar to dynamic arrays, fast to access by index, but slower for inserting or deleting from the middle. Lists are used whenever you need to work with multiple items in a single variable. That includes storing a collection of data, like names, scores, or tasks, looping through items with for loops, managing dynamic input or output, or performing batch operation. Whether you're building a to-do app, analyzing data, or organizing files, lists are incredibly handy. Here are some must-know facts. Lists are ordered and mutable. They can contain mixed data types. You can add, remove, sort, and slice lists easily. Python includes tons of built-in list methods like append, pop, remove, and sort. You can nest lists, meaning a list can hold other lists. Let's check out a few examples to see lists in action. You can create lists by using assignment and with the list elements enclosed in square brackets. You can then access the elements using the square bracket notation with the element index. Here we create the list colors. Then we access the element red located at index 0. You can also access from the back of the list. Index -1 gives you the last element, -2 the second to last, and so on. Lists are mutable, so you can add elements or take away elements. Here, we use the append method to add yellow to the list. We then use the remove method to take green out of the list. Lists seem tailor-made for loops. In this example, we use a for loop to print each element in the list, in uppercase. List order is maintained, and generally it's in the order that the elements were added to the list. Here we use the list sort method to sort the list in numerical order. We can also slice a list to get at just a portion of the list. In this example, we slice from element 1 to element 2. Recall that the first index of the slice is inclusive, and the last indicated index is exclusive. Finally, we can also use nesting to store lists within lists. In this example, we have two lists stored within the list called matrix. Note how we provide two indices to get at a list element. The first index refers to the outer list, while the second index refers to the inner list. As you can see, Python's list is incredibly flexible and perfect for managing collections of any kind. That's a wrap on Python's list data structure. Whether you're building a beginner project or writing production code, you'll be using lists all the time. Mastering how to create, modify, and loop through lists is a core skill every Python developer needs. If you enjoyed this video, give it a like, hit that subscribe button, and leave a comment telling us your favorite Python list trick. See you next time, and happy coding!